And next we have on call. I can say he like I don't have actually the points that I can say because he has literally contributed in every possible domain that you can think about. Please have him on the call.
Yeah. So we have Gokul sir. I mean, he's just like pro in everything.
Hi,
And
sir. How are you, sir? I guess you're on mute.
yeah.
Hey, Arinim Tejaswa. Hello.
Yeah.
Hey.
Yes, sir. You are visible and looking really fine. Yes. So I was just introducing about you, like you name a domain, he has possibly done a contribution in that, like talking about machine learning, talking about blockchain development, security, AI, ML, pick anyone you want, and he has done a lot of work. So I just want to first appreciate for all the contributions that he's constantly doing for all of us and for all the community, that because we actually need that, right? We actually need all of the leaders actually come forward and help us, because this kind of information is needed on a daily basis. Like if these researchers, if these security researchers won't be sharing their valuable research with us, we won't be learning new concepts and won't be growing up in this field. So once again, welcome to Unchained 2022, sir. And it's the next second year, and I
Yeah,
hope things are going fine at your end. And yeah,
absolutely.
adding on to it, like he's my research partner as well. So we have done a lot of research together and talked in many of the conferences. So yeah, you possibly have seen us together on many of the talks together. So yeah, so with that, I won't be taking much of your time, sir. The stage is all yours,
Thank you.
and just rock it.
Thank you so much, Tejaswa and Arinim. I am really happy to see the second edition of Unchained in 2022 coming up. I mean, we have a lot of global experts on blockchain security, and great to know about Securium event. So, without further delay, let me start sharing my screen and take you to the presentation. If there is a delay in the delivery of content, I'll switch off my camera.
Okay. Arnhem, can you just change the overlay?
I'm just sharing my screen.
Okay.
Are you able to see my screen?
Yes, we can see it now.
Okay,
Perfect.
great. So we are learning, we are going through the Hyperledger Fabric, one of the early block permission blockchain platforms, which started as early as December 2015. So Hyperledger Fabric, why I've chosen Hyperledger Fabric is the way Hyperledger Fabric is engineered is very different from quite a lot of our open blockchain platforms in which I was working in the last few years, be it Ethereum, Polkadot, Cosmos, or Algorand or Eternity. Their model, be it the model about the identity, and be it about the identity and access management, or all about consensus. Everything is done in a very different manner. And interestingly, I mean, like, when you look at people who are trying to deploy blockchain first time in their enterprises, many of them are choosing Hyperledger Fabric. And since the smart contracts in Hyperledger Fabric is written in general purpose languages like Go, JavaScript, and Java, quite a lot of time the developer community is not very much aware of the issues or security challenges that can creep in Hyperledger Fabric based systems. So there would be a perception that since this is a permission system, it's a system with lot of standard security modules, we don't need to worry much about security. But that's besides the point. We in this session we'll be going through some of the key concepts, key components of Hyperledger Fabric, and how security challenges in these components need to be addressed. So, Fabric is a permission system. The identities are registered through a module called Membership Service Provider, and identities of participating nodes are again maintained by Membership Service Provider. For managing consensus, there is a particular module known as Ordering Service Node. Membership provider is one of the very critical component in the platform. It manages access by issuing credentials in the form of cryptographic certificates for authentication and authorization. This project started in December 2015. With the guidance and the leadership from Linux Foundation and 30 companies to set up a project to promote cross-industry blockchain technology collaboration. From that 2015 onwards, it has grown phenomenally, and it has grown in like both in depth and in breadth. We could say the next diagram will show you how versatile this Hyperledger project ecosystem right now. In this Hyperledger project community, the first one we could say first Fabric, Iroha were one of the early protocols, and then came Hyperledger, Baru, Sawtooth, Indy, Grid, and thereafter projects like Ares, Caliper, Cello, Explorer, Quilt, and Ursa. The interesting about the Hyperledger project ecosystem is many of them are interlinked or could be used in integration. For example, Hyperledger Caliper can be used to measure the performance of Hyperledger Fabric. Hyperledger Ursa can be used to add custom cryptographic libraries for digital signatures or zero knowledge proofs in Fabric and Indy. And Hyperledger, recently there is a new interesting project called Besu, which is doing a significant contribution towards the interoperability between Ethereum and Hyperledger Fabric. And Ares is a kind of a client which works very well with Indy. So let's now get into Hyperledger Fabric, as it is the focus of this discussion session today. This reference architecture diagram shows various components of Hyperledger Fabric, ranging from identity to identity, like we mentioned earlier. Membership service provider is a very crucial component in the identity, and it is very important since we are dealing with a permission system. So enrollment of credentials, or the attribute based authentication, all this is done through membership service provider. Then comes another set of modules for the ledger, the core ledger where the blockchain is generated. So the ledger consists of networking component and distributed system component. And also then there is another core module related to transactions. How do you get the transactions from decentralized applications and clients? So the transactions are ordered and validated. That life cycle, how the transactions are executed, ordered, and validated, that's quite different from the permissionless blockchain systems. And the chain code, the smart contracts in the Hyperledger Fabric are packaged inside a particular construct known as chain code, where it runs in a Docker container, and there is a registry of all the chain codes. So we will get into some of the details of smart contracts and chain code in this session, and the security and crypto services run commonly across. So identity, ledger, contracts. Then we have APIs, events, and SDKs to interact with all these modules in a individual manner or in a group based transactions. So to understand the key features of Hyperledger Fabric, the chain code, as we have mentioned in the previous slide, is the the the, the smart contract. So uh, chain codes are engineered in such a way that they are modularized chain. You will understand more about it when you're seeing the architecture diagram. The ledger consists of the interestingly, ledger has a file system module and a database module. That's quite interesting, we should understand. So this ledger consisting of two modules called one module is known as world state or a state database, and then we have specific ledger module. Both of them together gives a very good capability for us to query the database and use the data through these rich queries in various ways for different kind of computations. Channel is a interesting construct here, so that its channel is something like each channel functions as a independent blockchain inside the network. So it's like that's a very, I mean, so these there the we install chain code in the channel, and then we maintain data, private data and the public data inside the channel. So channels provide a high degree of privacy and confidentiality. Now comes the security and membership services. So that's what we have mentioned earlier, the membership service provider. And consensus part, with regard to consensus, Hyperledger Fabric has been evolving from the early versions known as 0.6 to zero point 0.4, zero point 0.6, then a major version known as 1.4, 2.2, 2.3. Now, the major consensus algorithm used in the version is called Raft, which is an innovation over a very famous, one of the early consensus algorithm known as Paxos. So let's see the components in Hyperledger Fabric in a diagrammatic manner. As you see in this diagram, the overarching block, the box is the blockchain network. The S indicates the chain code, which are the contracts that are deployed on uh, the peers which are connected in the channel. So P indicates the peers, and O indicates the orderer which is ordering the transactions, applying the consensus. The L block indicates the ledger. So you can see the chain codes are deployed on peers, and the peers which are, they each of them maintain their own ledger copy, and they join a channel, and applications connect to the channel. As we applications are the connecting to the channel communicate via channel. The security modules, they also communicate via the channel. So as you see here in the diagram, T1 indicates the transaction with the proposal P, and the response to the transaction, when you submit a proposal, you get a response to the proposal which is endorsed by the endorsing peer. There are different type of peers in Hyperledger Fabric, which we will understand in the coming slides. So this diagram shows major components. So in Hyperledger Fabric, smart, like we heard before, the smart contracts are mentioned as chain code, and the networks use chain code uh, to regulate reading of the content inside the blockchain. Content, we will connect to the content or the data through the state databases. So the data is stored in databases, the state database, and these chain codes interact with the state database. You write your own logic, execution logic also in the chain code, which does the logical processing. And the node supporting the endorsement process. The what happens is after the endorsement, the network install and instantiate the chain code, and then so this happens with the client. Let me show you the flow. First, the transaction proposal comes in from the client. The transactions are simulated by the endorsing peer, as you see in the second step, and then once it is simulated and the something known as a read write set is generated, we get the response. The response is sent back to the client, and then once this much is fine, the transactions are submitted to the orderer. Then the transaction ordering happens and the new block creation happens. Then all these details are delivered through events. If you go a little bit into the details, this is what happens. The applications, the client side decentralized applications, they communicate to the peers through a proposal. They submit the proposal, and the endorsing peers who are friend ending, they execute the chain code to simulate the proposal in the peer. This is interesting. This kind of a simulation, the simulation model is unique to the Hyperledger Fabric architecture. So what happens after this? After the simulation, it creates something known as a read-write set. Once the read-write set is generated properly, the proposal response is sent back, and then once this with the read-write set you get the response, the SDK again submit the transaction to the ordering service. The ordering service then create a batch of transactions based on the configuration we have done. You can group transactions, or either it is based on the minimum number of transactions you mentioned inside the configuration. It could be 10, 20, etc. Or it is based on the block timeout in seconds. And thereafter, once the ordering service create the batch of transactions, then the transactions are committed to the peers, all the peers. So what happens in the committing phase is very important. So the committing peer, they receive batch of transaction from ordering service, they validate transactions, and they validate the endorsement policy. Then they validate the read set version in the state database, commit block into blockchain, and commit valid transactions to the state database. So this much is happening inside a particular transaction. So when you look at this component, what we have is the crucial component is an ordering service, which is connected to peers. Each of the peer has their own ledger where they can contain both block and world state. They also can contain something known as private data for scenarios when you want to maintain some data exclusively within the ledger for private communication. Even when the peers join the channel, they don't want to share all the data in the channel. So such data is maintained in private data. And chain codes are installed and instantiated in the peers through the lifecycle. And then the security, the identity management is done through a module known as certificate authority and something known as a membership service provider. Each certificate authority has their own certificate database. It could be a cloud-based database. You can use something like Amazon Key Management Service, or you can use a database like PostgreSQL, or by native, an SQL Lite DB is coming up, is there. Okay, so why this architectural approach is very different? What we have seen in Fabric, how is it very different? Traditional blockchain platforms, both permissioned and permissionless one, follow a sequential execution style. Even if you look at systems like whether permissionless systems like Ethereum, Bitcoin, or Algorand, and Polkadot, or you look at the permission systems like Corda or Hashgraph, Hedera Hashgraph, there is a sequential execution style. The transactions are executed after the consent, or they are entwined where all the participants execute the contracts. So it's like transaction ordering and execute architecture. So from the Fabric point of view, Fabric has achieved transactions per second as high as 20,000 or between 3,000 to 20,000, right? So this kind of an order execute architecture limits the scalability, and hence the sequential model has its own challenges. That's why here the model is different. Here, Hyperledger Fabric introduces the model where it helps us to prevent the scenario where there will be race conditions or some and security issues or very heavy attacks on the ordering system, right? So this architecture is known as execute order validate architecture, and this execute order validate architecture is a kind of hybrid replication model. As per Hyperledger, it combines passive and active replication in the Byzantine fault-tolerant model. How is it passive? It is passive in the sense that every transaction is executed or endorsed by a subset of peers, not by all the peers. And these peers can do this concurrently, or they can do it in a parallel execution manner without getting into race condition. Okay, so and because of this, transactions of the ledger are written only after consensus is reached. That's why when we saw the diagram, committing transactions, the validation and committing happens only after the consensus is reached, or when the orderer batches all the transactions. So there is initially a passive replication and then there is an active replication. This hybrid replication supports is made possible by using policies. These policies are known as endorsement policies that helps the Fabric to come up with application specific trust assumptions. For example, you can have specific endorsement policies in different channels. You can have multiple channels in the system. Transactions doesn't have to be constructed all in one order. Okay, so we mentioned about chain codes. Before I get into further details, let me show you Fabric infrastructure quickly. I hope I'm audible till now.
Yeah, you are completely audible.
Okay, and now I'm going into my environment. I hope you can see my environment.
Yes, yes.
Okay, so what I'm going to do is I'm going to show you my Hyperledger Fabric infrastructure. This is the Hyperledger 4.2, which is the long-term supported version. Here I am let me start the Fabric infrastructure. So first it will stop any other parallel running infrastructure. All these components are Docker containers. So I think, okay, it is now, since this is already a created network, it is now trying to create a channel. I will explain the components once this is done. So it is, so what you are seeing here is, it is creating a channel. Initially, it is looking at the Docker version, the certificate authority, and then it is creating the network first. Initially, it will create the identity, then it is enrolling the certificate authority admin. Okay, you have to look at, there is a config file for, this is the certificate module, and this is the config file for the certificate client. So there is a client and server for certificate authority. It is very important that the TLS should be enabled, and the client certificate is stored here. Then there is something known as, basically it comes with a one certificate authority, but if you want more, you can create intermediary certificate authorities. Now after enrolling the certificate authority, you are registering the peer. So this is the way by which you are creating an authenticated identity for the peers, and afterwards the users are created, and then it registers the organization admin. So peers are part of the organizations, and then for the first peer 0, the membership service provider is generated, and then it is generating the TLS certificates, and now it is generating the membership service provider, and then it is generating the membership service provider for the organization admin, and now it is creating the organization 2, and it's enrolling the certificate authority admin. It's registering the peer 0 into the second organization. Now the same steps are repeated for the second organization. Afterwards, what you're seeing is it is creating the peer state database, which is on CouchDB. For this particular this network, it is on CouchDB, the state database. And now you can see all the running containers, the Fabric peers, the CouchDB container, then the orderer, then the certificate authority, and thereafter it is running the command to create the channel. So each channel is a individual blockchain, and then it is taking snapshot. So once the channel is created, you have the details about the channel. Then the peers are joining the channel. Yeah, and then you're fetching the block details, and then you are setting a specific kind of peer known as anchor peer, which we will understand shortly. So once this much is done, so it is set anchor peer for both the channel for both the organization, and then it is trying to deploy. It is trying to deploy the chain codes which are already created. Chain code is the contract. First step is installing the chain code on the peer, and then the peer lifecycle begins. The chain code is packaged. Chain code is installed on peer 0 for both the organizations. The chain code query is done. Now after this, the chain code has to be approved on channels. So this is a different approach than what you see in Ethereum, this approval process. This gives furthermore control of the smart contracts. So the chain code definition is approved, and then chain code definition is committed once it is approved, and then afterwards, once the chain code is approved and committed, you can invoke, and you can invoke those chain code to do transactions. So this is the running network. I'm showing something known as Fabric samples. You can see lot of sample networks created here. There is a network for auction. There is a network for maintaining private data. There is there is something known as uh, if you want to create a highly scalable system that is high throughput, when you want to deploy all this into Kubernetes, this is a sample system with implementation on Kubernetes. If you want to create tokens, these are sample networks for ERC20 and ERC721. So that's about Hyperledger Fabric samples, which you can find it from the Hyperledger organization in GitHub. Now let me come back to the presentation. So we are talking about the chain code here. I think I have some time constraints, so I'm moving a little faster here. So what happens to the chain code? Chain code, what you have seen, you can invoke a chain code, right? Chain code can put the data and get the data. Uh, these two functions are used very frequently when you're writing a chain code. So what is the life cycle of a chain code? First, you connect to the peer. If the chain code is already installed, you invoke the chain code for the proposal. Then you get the response from the peer, and then you are requesting to the ordering service to order the transaction. What happens in that stage? Initially, transaction sent to the peers in block. The peers update the ledger using the block. Maybe so only initially the chain code is coming into one peer, but you have a network of 3 peer in an organization. In that case, the transaction is sent to all the other peer by the orderer. Okay, and the chain code generate query and update the response. So I know this is very little time to understand the complete architecture of Hyperledger Fabric, but please understand what you have is peers. Peers join the organizations, and peers join the channel. Organization is a collection of different type of peers, and channel is where multiple organizations come together or peers come together. Okay, so when you look at the data, the architecture, you have a world state where you can have both public data and private data. Private data is useful when you are dealing with privacy protection related use cases. And in the ledger, so the Hyperledger's ledger consists of world state and the blockchain. So the data in the world state can be stored in the form of key value or key value pair. Okay, so this is the general blockchain data structure. I'm just going into the type of peers. Like I mentioned, endorsing peer is the peer which directly interface with the clients or SDK. And then there is anchor peer which does the communication with the other peer. Then there is a third type of peer known as leader peer, and fourth is the common. Every peer is a committer. Okay, so, but we have to understand the difference between anchor peer and leader peer clearly. Anchor peer is a peer in a channel that all the other peers can discover and communicate with. So every organization in a channel will have an anchor peer. Leader peer is something which communicates with the ordering service. When the ordering service must send a block to the peer, it sends to the block to leader peer. Leader peer could be selected either by a voting or it can be selected statically. So here in the latest version of Fabric, we have the Fabric consensus known as the Raft consensus. Raft, an improvement over the Paxos consensus, which was proposed by Leslie Lamport in the early 1980s. So it is a very simple consensus model where there is a leader election, and the leader will be elected from followers, and the leader is selected for a term, and once the term is finished, then the leader is selected from the candidates. This diagram shows it very simple. When the starting, everyone is a follower and everyone want to participate in the election, and from all the candidates a leader is selected, and it could be once or either if there is a majority of vote. Only if the majority of vote is received, the leader will be selected, and then once the term expires, a new leader is elected from the followers. It follows a replicated state machine model. In the raft consensus, normally we will have odd number of consenters. It could be 3, 5, 7, 9, etc. So this is how any consensus algorithm can be drawn. Okay, so now we are getting into the crux of our session, Hyperledger Fabric security. So, like we mentioned earlier, the Hyperledger Fabric's threats differ from permissionless chains. Majority of the common attacks like 51% attack or partitioning attack, they are not significant threat to a permission system like Fabric, because here identity is known, identity is validated the moment even before you join the network, and then the activities are monitored and access is managed by access control list. So here but the attacks, like other attacks like denial of service attacks or consensus manipulation or smart contract vulnerabilities, these attacks become prominent here. And there could be another attacks on the most important component known as membership service provider. Let's look at these attacks. Before that, let us list all these components. The major components are the identity management modules, the certificate authority server and certificate authority client, membership service provider, the policies that we write for endorsement, channel level policies, chain code lifecycle policies. All these policies are important. Then very important to enable TLS, transport layer security. And if you're dealing with very highly confidential use cases, it is good to use a hardware security module in conjunction with all this. Okay, when you look at the functional security of Fabric, connecting TLS encryption and proper certificate handling are two important aspects. So the configuration of certificate authority with proper key management is very important. It could be stored either native or on cloud. And you can also do attribute based access control for the chain code for specific, for example, if you want specific kind of permissions for the clients to validate their permission and their roles before they execute a chain code, that can be done through attribute based access control. And along with, like we mentioned, along with enabling TLS based client authentication on peer node is another very important aspect. Apart from this network level, on the host level also, there could be attacks, possible attacks. So that is why on cloud we can use something like AWS key management service, or we can do native encryption on the host. This is the diagrammatic representation of Fabric CA. So this is the network of in an organization. This could be endorsing peer, anchor peer, leader peer. So the first they talk to, this is the endorsing peer, and this could be an anchor peer. Others could be committing peer, or one among them could be leader peer. So the Fabric root server interacts with the intermediate server and then checks the and then through the SDK you check the enrollment, and the Fabric CA client is available. You can connect to the server through command line CLI. You can connect to the CA server using the command line, and you can, if you want high availability for the certificate authority, you can maintain a cluster of certificate authority server. This is how the interaction happens between the root CA and the intermediary CA. Okay, so a certificate authority provides registration features like registration of identities, or if you want to connect with your enterprise LDAP, you can do that. Connect enterprise LDAP and use as the user registry together with the certificate authority. You can issue enrollment certificates which can be validated by the from your client side. You can even revoke the certificates. That's the feature added recently. You can renew the certificate and revoke the certificate. Certificate authority consists of server and the client component. The CS server should always be started with enabling TLS. So when you look at the identity management, we have seen these details. So there are two ways, like we mentioned. The earlier, the most important way is we generate a digital certificate, an X509 digital certificate issued by certificate authority. In some cases, when you don't want to reveal the identity of the participating nodes or peers, you can use something known as identity mixer, which is a feature recently added. Identity mixer uses the concept of zero knowledge proof. So the identity you can't it's unlinkable. You can't trace the identity of the peers when you're using identity mixer, but it can be verified. So normally the identity verification happens from the membership service provider. Membership service provider is the trusted authority. So it's a component that defines the rules for every organization in Fabric. So in Hyperledger Fabric, channels define a set of organization membership service provider, and then default MSP uses X509 certificate issued by certificate authority. Adopting it's a simple public key infrastructure hierarchical model. That's how you're able to have a root certificate and intermediary certificates. Now, other important component is the policies. The policies represent how members agree on accepting or rejecting changes to the network. For example, you want to say the endorsement should be done by both peer 0 and peer 1. So then you will say and policy. Otherwise, if you want to say if either of the endorsing peers can endorse it, then you use the or policy. So this is how these policies can be written. These policies can be written in the channel, or it can be written also at the chain code level. Now let us quickly look at the attack vectors we mentioned. The denial of service attack is one of the more prominent attack possible on the Hyperledger Fabric system. Other attack vector possible is the consensus manipulation. We have to understand that the consensus algorithms used currently, Raft, is only crash fault tolerant. There is ongoing research going on adding Byzantine fault tolerant algorithm like BFT Smart. So even regardless of the consensus algorithm used, there could be if there is a dishonest ordering service, a malicious ordering service, that attack vector is quite possible. That's why consensus manipulation is a possible attack vector. Then another possible attack vector is compromise of membership service provider. This membership service provider is able to modify access control to the network. So if any malicious attacker want to perform civil attacks, it can be done by compromising the membership service provider. It could be a rogue insider or through a private key theft, which has to be those chances has to be eliminated to the maximum possible. Maximum possible. Like, to mitigate this risk, it is important to follow the best practices with key management and logging every action of the membership service provider, such as certificate creation and revocation. And likewise, for the ordering service node also, it is very important to monitor the ordering service node actions. You can either integrate Splunk or you can use Prometheus with this. So there are a set of attack vectors possible in the chain code, or the risk if you're using any kind of randomness in chain code, or if you're using any external timestamp, or if you're iterating over a map object or calling an external API, using global variables, Go routines, range queries. You have to be very careful because they all open up possibilities of attacks. There is, but if your functionality mandates the use of them, you have to be very careful using them, especially with randomness, timestamp, Go routines, external libraries, global variables, etc. So when you look at these vulnerabilities, the object reification, this is an attack vector possible through a pointer. So using reified objects can cause non-determinism and create race condition. Global variables which are not stored on the ledger can also be uh, another which can also introduce inconsistencies. When you use system timestamp, it is very difficult to ensure that the timestamps are run concurrently in each peer. And like we mentioned, map structure iteration. Due to hidden implementation details of the, if you're writing chain code in Go language, when an iteration over map structure is used, uh, the non-determinism can arise, and then order of key values may change. That could create problems with the data that you're storing in the state database. When you're you doing concurrency with the chain code, if multiple transactions are executed concurrently under high load, the key versions the can change, and it could possibly create key collisions and can even result in double spending. If a transaction has passed from endorsing phase, and it's again, this is also similar, the if the key is manipulated after the endorsement phase, it can before it reaches the validation phase again, there could be a key manipulation attack. So range query is a kind of query that you run on the Fabric's state database. You are running the query across a set of maybe you've run a batch of transactions. Now you want to query them and get the compute the value, or you want to compute what has happened in this particular range. All those kind of queries has to be done very carefully. So I think I've crossed the time limit. The other two attack vectors are chain code sandboxing. When the chain code is executed in an isolated chain code Docker container with sufficient privileges, their escape is a possibility. It can be exploited in a malicious way, such as port scanning, or like I mentioned, container escape, identify and exploit vulnerable peers. All those are possibilities. Log injection is another kind of attack vector possible, any corruption of the log messages. So when you look at the mitigations of these attack vectors, importantly, monitoring the orderer, membership service provider, these are very very important. And other important thing is using the once the Byzantine fault tolerant algorithms are available, Hyperledger Fabric would be furthermore secure to BFT, Byzantine BFT kind of attacks. There are like more uh, in the pseudo-anonymous endorsing peers, which uses verifiable random functions, are a possibility. And then maybe in the future, when zero knowledge proofs become more easily accessible in Hyperledger Fabric, that could help improve the security of the identity, so that unlinkable identity based verifications can be done. So this diagram shows what are the possible attacks, and what are the membership service provider. If SGX enabled membership service provider is used, that could be a good solution. That could be like you can use Intel SGX or other hardware security mode, or you can do any other trusted execution environments. That is another possibility to protect the membership service provider. So, smart contract security measures, timeline limitations of chain code execution can be employed. Like if you are using timestamp, timeline limitations could be one possible option. Chain code execution should be performed with privileges other than the root. The Go's crypto randomness package can be used other than any other randomness modules. So limiting the access to the trusted services is that other option. And then very importantly, the key collision should be avoided by doing the version control. The on the when you're using the when you're using there is an option to use composite keys in Hyperledger Fabric. When you do use composite keys with version control, key collision issues can be mitigated. So, with this, I would like to conclude the session. Uh, there are more possibilities for privacy protection using private data collections and channels, which, due to time limitation, I don't want to go into those details. But with this, what I have covered is what is the general architecture of Hyperledger Fabric, how is it different from other permissioned and permissionless blockchain protocols, and what are the key components for security, and what are the attack vectors, and what are the risk mitigation methods. With this, please let me conclude my session.
Hi, sir. Can you hear us?
Yes, yes.
All right. Yeah, it was kind of a new experience, right, for most of us into the world of Hyperledger security, because we often talk about the security space of blockchain, the smart contracts, Ethereum, Binance, and yeah, the normal EVM based chains. And yeah, so like right now, we just started talking about the Rust based security,
Oh,
considering Polkadot, Solana, and all. But yes, talking about the space of Hyperledger is I guess pretty new and pretty much unexplored right now. And yes, you have actually given insights, and yes, people are saying this was actually interesting. But I'm sure people are having less information about this Hyperledger security. Like let's keep this in the same category where the Ethereum was back in 2017-18. The
yeah,
Ethereum security, pretty much unexplored, scattered information. Everyone was
yeah,
trying to learn, but it was pretty hard for everyone to get into it. And I guess the same thing is going on with Hyperledger security. The
yeah,
chain code and things are new, but yes, we'll surely be having a boost after this session, and
yeah,
much more with these kind of sessions. So we want these kind of sessions at a scale of 10x to promote Hyperledger security as well.
yeah.
But yes, oh my god, wow, how many things were there, so many new things that I have learned, and I will be exploring myself Hyperledger security.
That would
And
be
yes,
great, Tejaswa and Arunam. See, this is a differently engineered system.
right,
So their design philosophy itself is very different. So it took me also a while to understand this. But if you understand it would be very interesting to look at from a distributed system standpoint. You will get to play around with lot of security components which are used
right,
in industry and enterprises traditionally, and to
yes,
test how secure they are. So it's an interesting journey if people like you who are deep into the security world comes into Hyperledger Fabric security. I am very sure we'll have more utilities, more libraries, more security audit reports would be there,
Mhm.
and that would
Right.
really help this enterprises. Not only enterprises, there are a lot
Mhm.
of startups which are
Right.
doing a great work on Hyperledger Fabric.
Mhm.
So they will all benefit a lot, and the community will benefit a lot if security researchers spend more time with Fabric. That's why I wanted to give this introduction.
Right.
Please
Yes.
consider this only as
And
an
it was,
introduction session.
yes, it was kind of something we can take beyond blockchain, right? So
Yeah,
it's like the conference right now we can point it out, not just blockchain specific, we can say decentralized security, right? So
yeah, yeah.
it's not just limited to blockchain now. So I guess hopefully sooner we will be having more talks over like DAX and lattices as well, like beyond even Hyperledger and things like that.
Yeah,
So
yeah.
hoping the best. But yes, so this was completely new insights from your side, and what we can say, we can just say
I was
thanks you.
actually thinking, should I take a session on Polkadot security or Fabric security? I've
You're always
chosen
free to do
Fabric
so, sir.
because I wanted more. I wanted more attention on this,
Mhm,
if possible, and more work, because there are only very few libraries which are doing chain code audits. Uh,
mhm,
Maybe in the public domain, but then
mhm,
if a community looks at it, it will be great.
mhm.
It will be good for the general community and also for the Hyperledger ecosystem.
Right, right. Yes, that will definitely help a lot. And like, if you want us to share some resources, video slides, please let us know. Any approach that you want to provide to the new learners, right? How to get started? Like, if they want to learn, like, first of all, the Hyperledger itself, the tech stack, and then come into the security part itself. So if you have a like a general approach to follow, please let us know. We'll
Yeah,
link
yeah.
and attach
Can
to
I
your
share
slide.
one more slide? I mean,
Yeah, yeah,
I've
please,
created
please, sure.
I'm just trying to, yeah,
Mhm.
I'll just show you in GitHub. Please, I've curated, uh, if you come to, I've curated set of material fabric which could
Mhm.
be useful. I will share it. This is my curation. So you will get material on different aspects of Hyperledger Fabric: consensus,
Mhm.
performance, chain code, best practices, testing,
Mhm.
security. So please let me share this link in the chat.
Mhm.
I am not sure if I'm able to share in the chat. I'll share this with
Uh,
you all.
okay. Arvind, have you received it?
No,
Uh,
no, I'm not able to share the chat.
okay.
Okay.
You can just drop in the private chat and you will
You
just.
can drop in the private chat that we have, and you can
Yeah, yeah.
share.
I just shared in my
Yes,
private chat to
correct,
Tejas.
correct.
So thank you once again, team RazorSec, Arvind, Tejaswa,
Thank you.
Quill Hash, Quill Audits, for giving me opportunity. This was in the second edition of Unchained. It's a great honor.
It's an honor for us
Thank you,
to
thank
have
you.
you with us. But yep.
I really enjoy this community and fraternity.
Mhm.
Wish you all the very best for this ecosystem and
Thank you.
this platform.
Thank you.
And yes, yeah, thank you so much for all the best wishes.
Thank you.
And we always will be seeking your support, like
Pleasure.
as individual members and as community members as well. So once again, thanks for your contributions and just keep doing it. We don't want you to stop like any moment. Just keep on doing it and
Sure,
just
sure. With
help.
all your support, I will
Yes.
contribute more as much as I can. Thank you once again.
Mhm.
Signing off.
Right. Thank you so much, sir.